Welcome to Efiwe, excellence without stress.
Hi guys, we are back again on this our journey, and today our topic will be temperature and its measurement. We're going to learn about different types of measurements involving temperatures. So what is heat? Heat is a measure of the total internal energy of a body. It is a form of energy due to a temperature difference, and the unit of heat is what is joule. There's a difference between heat and temperature. What is temperature? Temperature is a degree of hotness or coldness of the body, and it's related to the energy movement. Temperature is measured in degrees Celsius or Kelvin. So this is the difference between heat and temperature. Temperature is a degree of hotness or coldness of the body, and it is actually related to the energy of movement. Methods of measuring temperature. Our sense of touch can give us a general impression of the degree of hotness or coldness of a body, but it is not a reliable method. Warm water will feel cool if a hand initially dipped in hot water is transferred to it. S. In order to gauge accurately the exact degree of hotness, an instrument called the thermometer is used. So the thermometer is the instrument used for measuring temperature. Thermometers use any physical property of a substance which varies in a known way with temperature, and it is easily measurable as a means of gauging temperature. The substance of whose physical property is to be used is known as a thermometric substance. Thermometric substance. Fixed temperature and temperature scales of thermometer. Each thermometer has two reference temperature or fixed points called the upper fixed temperature point and the lower fixed temperature point. The difference in temperature between the two temperature points is called the fundamental interval or the temperature interval of a thermometer. The calibration of this interval depends on the temperature scale choosing. There are three types of scales in current use. We have the Celsius scale, we have the Fahrenheit scale, and the absolute or thermodynamic or the Kelvin scales, and each of them have different upper and lower fixed point. The upper fixed point is the temperature of steam from pure water boiling at standard atmospheric pressure of 760 mm of mercury, while the lower fixed point is the temperature of the pure melting ice at the standard atmospheric pressure of 760 mm of mercury. The lower and upper fixed points are 0 degrees Celsius and 100 degrees Celsius. So we have these thermometers now. We have three thermometers and different temperature scales. We have the Kelvin scale, we have the Celsius, and we have the Fahrenheit. For the Kelvin, the lower fixed point is 273. That's the point that water freezes. So for the Kelvin scale, we have the water freezes at 273 Kelvin and water boils at 373 Kelvin. So the lower and upper fixed points are 0 degrees Celsius and 100 degrees Celsius for the Celsius scale. Ideally, the Celsius and the Kelvin scales are related because between the lower fixed point of Celsius and the upper fixed point of Celsius, we have 100 calibrations. The same thing goes for the Kelvin, which is 273 to 373. If you subtract 273 from 373, you're also going to get 100. While the Fahrenheit, the lower fixed point, which is the point where water freezes, is 32 degrees Fahrenheit, and the upper fixed point, which is the boiling point, is 212 degrees Fahrenheit. So the lower and upper fixed points are 0 degrees Celsius and 100 degrees Celsius for the Celsius scale, 32 degrees Fahrenheit and 212 degrees Fahrenheit for the Fahrenheit scale. And the fundamental interval in the Celsius scale is divided into 100 equal parts. Each part of the Celsius defines 1 degree Celsius on this scale. For the Fahrenheit scale, the fundamental interval is divided into 180 units or degree of Fahrenheit. The SI unit of the temperature is Kelvin, and the scale is called the absolute or thermodynamic temperature scale. And that is all about the three scales: the Kelvin, the Celsius, and the Fahrenheit. So a temperature of theta degrees Celsius in the Celsius scale is related to T of the Kelvin scale by T is equals to theta plus 273. So if you want to get a temperature in Celsius. You want to convert Kelvin to Celsius, you're just going to add it to 273. So the upper fixed point on the Kelvin scale is 373 Kelvin or 100 degrees Celsius. Nevertheless, a temperature change of 1 degree Celsius is equal to a temperature change of 1 Kelvin. That was what I was trying to say. They are related because the interval between 273 and 373 is equal to 0 and 100. That's for the Kelvin and the Celsius scale. The upper fixed point of an unmanned thermometer can be determined using a hypsometer, a double-walled copper vessel constructed. So if you want to get the upper fixed point of an unmanned thermometer, we can use the hypsometer to do that. The lower fixed point. The lower fixed point is determined by placing the thermometer upright in pure melting ice containing a glass funnel. In pure, you can see it from this diagram here, in pure melting ice containing a glass funnel. When the mercury level remains steady for some time, a mark is made on the stem of the thermometer to indicate this level, which represents the lower fixed point, the lower temperature fixed point. And for the upper fixed point, we use the word hypsometer. We use the hypsometer to do that, to get the upper fixed point of the unmarked thermometer. So let's just try to calculate the upper or lower fixed point of a given thermometer with all the formulas we've got. You know, we said that. Let's go to our board. So we talked about the Celsius scale and we talked about the Kelvin scale. We said that for the Celsius scale, the lower fixed point or the ice point is what? 0 degrees Celsius, while the upper fixed point or the boiling point is what? 100 degrees Celsius. You know, we know that water boils at 100 degrees Celsius. And for the Kelvin scale, we have what? We have 273 Kelvin for the freezing point, and we have what? 373 Kelvin for the boiling point. So look at this question now. The question says the upper and lower fixed points of a thermometer are 90 and 10 respectively. So determine the temperature on the Kelvin scale when the reading is what? Is on T, which is what? 30. So this one we don't even know, maybe it's Kelvin, maybe it's Fahrenheit or for Celsius, but we're told that we're given the upper and lower point of the thermometer. This is a thermometer. We don't know the scale of the thermometer, but they gave us the upper and the lower and the middle part. So this is the upper point. It was 90. The lower point, which is the freezing point, was 10. And they also gave us the interval, the middle part, which is what? 30. And they asked us to compare it with the Kelvin scale. So we were asked to compare it with the Kelvin scale. So we have 90 here, we have 30 here, and we have 10 on this thermometer that we don't know, maybe it's for Celsius. So we want to compare it to Kelvin. Don't forget that Kelvin, Celsius, and the Fahrenheit, they have a fixed upper point and the lower scale. They have a fixed one. So we just have to write 373 Kelvin here. It doesn't change, and we have the 273 Kelvin. So the part that we cannot know will always be this part. This is the part that we cannot know. The 373 and the 273 is constant, and for Celsius the 100 and the 0 degrees Celsius is what? Is constant. So we were asked to look for this part. So how can we get that? It is so simple. What you just need to do is you do some subtraction and relate these two. So the thermometer 1 is equal to the Kelvin scale thermometer. Kelvin scale thermometer. So look at it now. What you just do is you subtract the middle from the freezing point. You subtract also the upper scale from the freezing point, the middle scale from the freezing scale, and also the upper scale from the freezing scale. So that will be what? 30 minus 10 divided by 90 minus 10. As you do it for the thermometer that you don't know the scale, then you go to the other side also and do the same thing. So this one now we don't know this part. We're going to put x. So that's just going to be x minus 273, which is also equal to what? The boiling point minus the what? The freezing scale point. So that's 373 minus what? 273. So that is how to just get it. Anytime you are giving, just remember that this upper and lower fixed of each thermometer is fixed. For the Celsius, for the Kelvin is 373 and 273 is the freezing point, while for the Celsius is 100 degrees Celsius for the boiling point and 0 degrees Celsius. So the only part you can look for is actually this middle. This is the part you can be asked to look for, and that's what we are trying to do here now. So we already have it. So 30 minus 0 is what? Is 30, right? So that's 30 divided by 90 minus 10 is what? Is 80. So we're going to equate it also to what? X minus 273, because we don't know what x is. We're going to put 273 divided by 373 minus 273 is what? Is 100. So we know we're going to definitely cross multiply. So that will be, okay, that will be 20. No, sorry, 30 minus 10 is 20, not. So that will be 20 divided by 80, right? Is equals to x minus 273 over 100. So let's cross multiply. So we have it as 20 times 100 is equals to 80 multiplied by x minus 273. So this is 2000 is equals to 80 multiplied by x, will give you 80x. And 80 multiplied by 273, let's do that with our calculator. 80 multiplied by 273. It's 80 multiplied by 273 is 21840. So 80 multiplied by 273 is, I'm going to say minus 21840. So we have that. So we're going to bring this to this side. Let me just write it here, because that place is already getting clustered. We have 2000 is equals to 80x minus 21840. So that will be 2000 plus 21840 is equals to what? 80x. So we know that our x will just be 2000 plus 21840 divided by 80, and we're going to get 298 Kelvin. We're going to get 298 Kelvin. So that's how to solve it. That's how to relate two temperatures, two thermometers together. So we did not know what this one was measuring, but we can compare it to a known thermometer. We can compare, so 30 of this one is equated to 298 Kelvin. So 30 from this thermometer is equated to what? 298 Kelvin. So we are able to know the measurement of this thermometer, even though we don't know the scale of the thermometer. So let's go to the next question. Let's go to the next question. The next question says the lower and upper fixed points of a thermometer are 30 millimeter and 180 millimeter. So we have it as the lower and upper are 30 millimeter. You know that the lower point is the freezing point and the upper point is the boiling point. So it said calculate the temperature in degrees Celsius when the thermometer reads 45 millimeter. So we have it now. We have 180, 30 and 45 millimeter. So let's go to our board. So let's delete this. Let's go to our board to work that. So we are given that the thermometer was, the upper part was 180, the lower part was 30, and the middle part was what? Was 45. So you know we have a constant scale for the Celsius thermometer. So we have this one to be 100, and we have this one to be what? 0. So we are looking for the relationship at this point. So as I explained in the former example, we are going to subtract this from the what's it called, the freezing point, and also we're going to take the upper part to the upper scale and subtract it from this. So that will be 45 minus 30 divided by 180 minus 30 is also equal to, we don't know this part, so we're going to represent it with x. So x minus 0 is equals to 100 minus 0. So 45 minus 30 is 15 divided by 150, and that will give us x divided by what? 100. So cross multiplying, we have 1500 is equals to 150x. So definitely our x is equals to 1500 divided by what? 150. So dividing this, we know we have what? We have 10. So that's 10 degrees Celsius, and we've gotten our answer. Our answer to be what? 10 degrees Celsius. So our answer is 10. So we've gotten, so the first question, the option was B, which was 298 Kelvin, and the other one is A, which is 10 degrees Celsius. So let's proceed. So types of thermometer. We have the liquid in glass thermometer. Liquid. So what liquid are we talking about? We have the mercury or the alcohol. We can't use water because water is transparent. So the liquids we can use are mercury or alcohol. So physical property: change the volume of the liquid with temperature. We also have gas thermometer, and the substance that we use will be gas. We have the resistance thermometer, and the thermometric substance is resistance wire. We have the thermocouple, and two dissimilar metals, e.g. copper and constantine, will be the thermometric substance. And we have the bimetallic thermometer, and the thermometric substance will be two dissimilar metals, e.g. iron and copper. The liquid in gas thermometer. The most common liquid used in thermometers are mercury and alcohol. The thermometer measures temperature by measuring the change in volume of a given mass of liquid due to a change in temperature. For high sensitivity, liquid in gas thermometers should have a bulb made of thin glass. This enables the liquid in the bulb to absorb the temperature of its surrounding quickly, because a thermometer must be very, very sensitive. So it must be able to access the temperature of its surrounding quickly. Also, a narrow capillary tube with uniform bore. This makes it possible for small temperature changes to cause large changes in the length of the mercury column. And also a liquid with high expansivity. To be used as a thermometric liquid, such a liquid should expand or contract uniformly and have a high boiling point and a low melting point, and be seen in glass. It shouldn't be transparent, it must be opaque. The temperature that we would use for the thermometer must be opaque. And that's for the liquid in gas thermometer. Water has none of the above properties. It has a small range of expansion. It freezes at 0 degrees Celsius and boils at 100 degrees Celsius. It does not expand uniformly. It also contracts from 0 degrees Celsius to 4 degrees Celsius. And it wets glass, and it is colorless, making the meniscus in glass difficult to read. The above reasons make water unsuitable as a thermometric liquid. Mercury in glass thermometers are more commonly used in school laboratories and hospitals than alcohol in glass. Mercury in glass thermometer is cheap and simple, but it is not reliable enough for accurate work. Comparison of mercury and alcohol as thermometric liquid. Mercury has a much greater conductivity than alcohol and expands rapidly, and thus indicates a temperature change very quickly. Alcohol, being a relatively poor conductor, expands slowly and thus respond to temperature changes slowly. Its slippery surface makes mercury opaque, and it can easily be seen. Alcohol has to be colored to be easily seen. Mercury does not wet glass, but alcohol does, because of its concave meniscus tends to cling to the walls of stem of the thermometer. This leads to an accurate reading when the thread is falling. Mercury is not easily vaporized, whereas alcohol is very easily vaporized even at low temperature. Mercury boils at 357 degrees Celsius, while alcohol boils at 78 degrees Celsius. Mercury can therefore be used to measure higher temperatures than alcohol. Alcohol has the following advantages over mercury as a thermometric liquid. It freezes at minus 115 degrees Celsius, whereas mercury freezes at minus 39 degrees Celsius. So alcohol can therefore be used for measuring very, very low temperatures. The expansivity of alcohol is about 6 times that of mercury for the same temperature rise. So the clinical thermometer, this is a form of mercury in glass. So the thermometric liquid is used is what? Is mercury. So this is a form of mercury in glass thermometer used in the hospitals for measuring the temperature of the human body. The temperature of a normal healthy body is about 37 degrees Celsius, but it may rise to about 41 degrees Celsius in cases of high fever. The temperature range of the clinical thermometer is therefore between 35 degrees Celsius to 43 degrees Celsius. The thermometer has a small bulb. You can see this is the small bulb, this is the constriction, and this is the what? Clinical thermometer, and this is a capillary tube, and that is where this liquid will be flowing, and wherever it stops will tell us the reading of the thermometer. The most prominent feature of the thermometer is the kink or constriction of ball near the bulb. The kink allows the expanding mercury to flow. It allows the expanding mercury to flow past it when the thermometer is placed in contact with the human body. Combined maximum thermometer and minimum. This is a type of liquid in glass thermometer used by weathermen. This is, look at it, maximum and minimum thermometer. So this is mercury maximum and this is its still index. So this is a type of liquid in glass thermometer used by weathermen in meteorological stations. It records both the maximum and minimum temperature for the day. The one most commonly used is the 6 combined maximum and minimum thermometer invented by Jamb 6. So we have the gas thermometer. This is the gas thermometer here. Mercury in glass thermometer are not very suitable for extremely accurate measurements for temperature. Their inaccuracy is due to the fact that the glass also expands with temperature in an irregular manner. Gas thermometers are therefore used for accurate temperature measurements. The principle of the gas thermometer is based on the fact that at constant volume, the pressure of a gas increases linearly with increase in temperature. So a constant volume gas thermometer consists of a large bulb which contains a gas, e.g. hydrogen or helium. The bulb is connected to a narrow glass tube and attached to a mercury thermometer. You can see the setup here, and attached to a mercury manometer. The advantage of this type of thermometer over other thermometer is that it is very sensitive, accurate, consistent, and has a wide range. Its major disadvantage is that it is large and cumbersome and therefore not suitable for measuring the temperatures of small volumes of liquid or small enclosures. It's also required a knowledge of the pressure of the gas at the fixed point anytime we require to use this instrument. So it's kind of complex than the normal mercury in glass thermometer. Thermoelectric thermometers. Such thermometers are used for measuring very, very high temperatures. They work on the principle of thermocouple. When two different metals, e.g. copper and constantan, are joined at the ends, and one end, the hot junction, is heated, while the other end, the cold junction, is kept constant in melting ice, an electric current flows along the metal. This is the thermoelectric effect, and the setup is called a thermocouple. So an instrument which uses a thermoelectric effect to measure temperature is known as a thermoelectric thermometer. It uses the thermoelectric effect to measure temperatures, and it is called the thermoelectric thermometer. And this is a thermoelectric thermometer. The size of the current is measured by sensitive galvanometer. We know we talked about galvanometer in our previous classes. It detects very little current, very small current, because it is very, very sensitive. So the size of the current is measured by a sensitive galvanometer, which is connected in series with the hot and cold junction, which is connected in series with the hot, and you see the hot junction here, and the cold junction. The current is dependent on the difference between the temperatures of the hot and cold junction. The galvanometer is usually calibrated to read the temperature of the hot junction directly. That is how it is calibrated to read the temperature of the hot junction. Such thermometers are used in industries for measuring high temperature. That's the thermoelectric thermometer. So the advantage of the thermometers are it is very sensitive and can measure rapidly changing or momentary temperatures. It is very sensitive. It can also measure high temperatures up to 500 degrees Celsius. It can measure temperature up to 500 degrees Celsius. It is very small in size and can therefore measure the temperature almost at any point. Then we have the resistance thermometer. This is the last type of thermometer we're going to talk about today. This thermometer uses the fact that the electrical resistance of a metallic conductor changes proportionally with its temperature. Yes, the more temperature, lesser resistance. So this thermometer uses the fact that the electrical resistance of a metallic conductor changes proportionally with its temperature. High temperature, the greater is the resistance. It consists of a long thin platinum wire wound round a small spool made of mica or silicon. This is the resistance thermometer, and it uses this fact that electrical resistance of a metallic conductor changes proportionally with its temperature. That is, it is directly proportional. Electrical resistance and temperature are proportional to each other, and this is the resistance thermometer. And that's all for today about temperature and its measurements. Resistance thermometer, the end of the wire are connected to a resistance measuring device. Let's just give some explanation about it, such as a Wheatstone bridge. In many cases, the resistance scale is calibrated to read the temperature directly in degrees. Resistance thermometers are useful in the accurate measurement of very low or very high temperatures, just like thermocouple. If, for example, a given platinum wire has a resistance of R0 at 0 degrees Celsius, then the temperature when its resistance is R is given by this. This is how to measure the temperature. That is R minus R0 divided by at 100 degrees Celsius minus at 0 degrees Celsius. So we can get the temperature at any point. And that's all for today. Thanks. See you in the next class.